For this week, our topic will be severe weather. The questions for discussion are: which types of severe weather risk are you willing to live with? What level of risk from severe weather is acceptable to you? How would you know if the severe weather risk was assessed accurately? And what should be done by people and communities to prepare for severe weather hazards and prevent catastrophe? Severe weather hazards are hazards with which we are all familiar. You will want to consider the factors that influence the impact of severe weather and how severe weather hazards vary from place to place and why they do that. We will focus on severe weather that we might encounter in Illinois. Some of you may be from outside the state, so you might want to think, what kind of severe weather hazards do you encounter in other places? But our focus will be, of course, in Illinois. So the first thing we want to do is just define the difference between weather and climate. Weather is the short-term conditions of the atmosphere at a given place and time. So the weather might be hot, it might be cold, it might be rainy, it might be dry, it might be windy, it might be calm. So those conditions of the atmosphere at a given place and time are what the weather is. Climate is the long-term average weather for a given place. And so climate varies very slowly because we're averaging things over extended periods of time. Weather, on the other hand, can vary pretty rapidly and dramatically, and changes occur sometimes in a very short period of time. When we watch the news at night, if we choose to do that, the so-called weather report actually includes weather and climate information. Most of it is weather. They tell you what happened today and what's likely to happen tomorrow and for the next few days. But for context, they also include the quote-unquote normal high and low, and also they usually say something about the records, and they might say something else that happened weather-wise on this day. Most of us are familiar with what the climate is like, and we're also familiar with the expected weather for a given location. So how does this all work? Well, the way that it works is our weather systems are driven by energy from the sun, and there's a nice discussion in your book about how this works. The reason that we need to know this for this class is because if we want to forecast the weather, we need to be aware of exactly what drives the system. So on the upper right, you can see the structure of the atmosphere from the thermosphere all the way down to where we live, which is called the troposphere. Most of the clouds we see occur within the troposphere as well. In the stratosphere, we have what's called the ozone layer, which protects us from ultraviolet light. On the lower left, you can see the energy that drives the system. We get incoming solar radiation. Some of it, 30% of it, is reflected back to space before it can do anything on the planet. 25% is absorbed directly by the atmosphere, but you'll notice that almost half is absorbed by the surface of the planet, either the oceans or the land. That absorbed energy is then re-radiated back into the atmosphere, either as heat or what we will discover is a very important driver, is evaporating water. That water, when it evaporates, holds a lot of energy. And when the water turns from vapor back into drops of water, that energy is released back into the atmosphere. Now, ultimately, all this energy goes back into space. So what we see in terms of weather here on the planet is the effect of this energy kind of moving around at the surface, before it goes back into space. So atmospheric circulation, generally speaking, we're seeing heat energy moving from the equator, where we get the most energy, toward the poles, where we get the least. There's a pretty complicated set of circumstances that occur here that if you take a weather and climate class, you can find out a lot more information about that. But essentially, this is driving our weather systems, this heat energy trying to make its way from the high energy area of the equator to the low energy area of the poles. This moving heat energy gives us wind, and some of that heat is also moved, in fact a lot of it is moved in the form of water vapor. When air rises, the pressure decreases, the water vapor condenses, turns into liquid, and gives off its energy. So rising air is another one of our drivers that we're going to look at. When the air is subsiding or sinking down, we don't see water vapor turning into liquid. In fact, the opposite often occurs. We see water vapor or liquid water turning into water vapor and kind of disappearing from our sight. So if you look in the upper right, where air subsides, we have what's called a high pressure system. And that usually is clear skies, or sometimes we see puffy cumulus clouds. And generally speaking, that is kind of quiet weather or dry weather. When the air rises, the water vapor condenses, water droplets form, and typically those water droplets will start to fall from the sky as some sort of precipitation. And that's a low pressure system because the air over your head is going up, so that's less pressure on you. So a weather map is shown in the lower right hand corner, and it shows H's for high pressure systems, L's for low pressure systems. They use the red with a little curve thing on it for what we call a warm front, and the blue with the triangles or the teeth is a cold front, and where they alternate between red and blue, that's what they call a stationary front, where it's not moving. Typically when a warm front goes past, you will get rain, rain showers over an extended period of time. When a cold front goes over you, you will get precipitation occurring very quickly in a short period of time. That's typically how we experience thunderstorms in Illinois. So a warm front will give you a day's worth of showers. A cold front will give you thunderstorms. They both give you rain, but it comes down in different ways. So this is what we call frontal weather, and these systems are called extratropical cyclones. Tropical cyclones are a weather system that we will discuss next week, because next week we're going to discuss hurricanes, which are tropical cyclones, and we will also discuss tsunamis next week. Those are both coastal hazards, so we're pushing tropical cyclones off. But this week the focus really is on frontal weather, because that's the kind of weather that we have in Illinois. And the frontal weather is associated with what are called extratropical cyclones. Now, cyclone just means that the storm system is rotating. A cyclone is not the same as a tornado. A tornado might be associated with an extratropical cyclone or a tropical cyclone. It is a small feature located within the larger cyclonic system. So, frontal weather, how does it work? Well, they show you on the lower right-hand side there a frontal system as it moves across North America. There's a boundary between cold air kind of pushing down from the north, warm air coming in from the south, and hot air will typically rise because it is less dense. The cold air will push underneath. And what you see in the series of little diagrams going across the top of that image on the lower right is we start with kind of a straight boundary between the cold and the warm air. And because the air on either side is going in opposite directions, it will form a twist in what's called the polar front. This creates our extratropical cyclone. The top three little diagrams on the lower right there show you the straight starting to get a little curved and then forming a cold and a warm front. If you drop underneath that image, you'll see the cold and warm fronts turning into an extratropical cyclone, which then moves across North America and gives us first a warm front. So you get showers for a day, and then a lot of times we get some kind of clear weather for a day, and then the cold front comes through and we get thunderstorms and we get cooler air. So that is how this type of system works. And these come through in the summer as well as the winter. In the summer we get showers and then thunderstorms. In the winter we get snow showers and then sometimes very heavy snow falling when the cold front arrives, and then cold weather afterwards. So these little diagrams on this picture show you the various types of systems. Because of time limitations, I want to keep moving through here. This is what we get in the summer. In the summer, the real dramatic kind of catastrophic storm is usually not the warm front. It's typically associated with the cold front. When the air rises very quickly, we get thunderstorms. That thunderstorm can give us lightning. It can also give us, they show that on the top here. On the bottom, they show the development of a large thunderstorm. That could give us hail. That updraft can grab falling drops of water that have maybe been super cooled and turned into ice. That updraft can take them back up into the cloud, get another coating of water to freeze on the outside, and eventually they're too heavy to stay up, and so they fall as hail. The downdraft gives us a strong wind sometimes. If you've been outside during a thunderstorm, you'll notice that right before the storm hits, there's usually a very strong wind, and that is the downdraft that you feel during the mature stage. There's a lot of information in your book about how thunderstorms work. Tornadoes are another aspect of this that occurs with the thundercloud here. You'll notice that the blue and the red arrows are going in opposite directions. That can start a whirling vortex in the cloud, and you'll notice that the opposite directions are really kind of in the back of the cloud here with the lightning, and typically that's where we see the tornadoes, kind of in the back side of the cloud because we've got the air going in the opposite directions. So that's how tornadoes form. And again, there's more information in your book, so you want to look at that. These diagrams also from your book show the risk of thunderstorms. You'll notice there's a pretty high risk in Illinois and throughout the Plains states. There's also a pretty high risk of thunderstorms and tornadoes in Florida. And you'll notice the risk as you go out west is quite a bit lower. So these systems also bring us blizzards and ice storms, and whether you get snow or ice really kind of depends on where you are temperature-wise in this system. And the bottom of the diagram here kind of gives you an idea of that. I wanted to mention droughts. There's a link on our resources page to the U.S. Drought Monitor. This is an image taken from the Drought Monitor from last week. You'll notice there is a very severe drought in the western United States, and in the central part of the U.S. we've been getting quite a bit of rain, so no drought there. Some other types of hazardous weather you might want to consider are fog, windstorms, dust and sandstorms, heat waves and cold